Hi roboticists, welcome back in this new video where we're gonna see how to attach a collision object to our robot, and this is a very important feature if we want to perform a manipulation application. So in fact, after attaching an object to the robot's body, or better the gripper, the obstacle avoidance algorithm is additionally extended to the grasped object. And so if you do like that, the robot will be free to move into its workspace, avoiding obstacles and carry out the object to manipulate. So before to start, make sure to subscribe to the channel in order to do not miss the next topic, and why not think of a donation for this channel that will be very useful for continuing this series in developing your software skills, and in particular with ROS in robotics. So now let's get started. So what we're gonna do is to open our Visual Studio Code, and we are gonna go into our Cobot Test library package, and what we are going to add here is another file, or better another C++ file, and we are gonna call it Attach, Detach, Object, Cobot. Okay, the first part of this script will be very similar to the add collision object that we have described in the last video. I'm gonna provide a link here. So we can set this apart. And so let's get started. So first of all, we need to include our libraries that we have added in the previous video of this series. This is going to be a move group interface and a planning scene interface. So in order to allow our robot to interact actively with the scene of our environment. Then, as always, we will need to have a main function here, where there will be the core of our script, and then from here nothing new. We just need to copy and paste this part of the code. We already discussed about it, but basically we are going to create a node and give it a name, and this will be, for example, the node Cobot Planner, we can call it. Then a node handle object, the spinner, and we can start. So now what we're gonna do is to initialize the group arm and the scene interface. So the scene interface is gonna be belonging to the planning scene interface, so we can just copy and paste this. Okay. We can call it, just for not making any confusion, planning scene interface, and then we need to initialize the group of our arm. So just do it. And for this we're gonna use the package move group interface, and then the group that we need to create is our arm. Here we have two planning scene interface. One is going to be the planning scene interface and one is going to be the current scene. And we're going to see this in a while. Then what we need to do is to wait for the scene initialization, and for example we can give a time of 2 seconds. So we're gonna sleep for 2 seconds, and then now we need to define the collision object to spawn into the scene. So till now nothing new that we have already seen, with the exception that this time we are gonna add let's say a cube. Then we are gonna give an ID to this cube. We can call it a grasping object, for example. And then what we're gonna do is to add this grasping object to the scene, and we have already did it before. And then we're gonna select the primitive type of this object, and this time instead of having a cylinder, this will be a cube. Then we are gonna give the size of this. We can have a cube of 0.03. It is gonna be 30 millimeters. And a height of 80. Then we need to define the position and orientation. And for making the thing simple, we can have this in position 1, 1, 1. This is a good practice because since that the base link is based in the 0, 0, 0, we know due to the square of the RV's environment if the object is spawned correctly in the right orientation and position as well. And then what we're going to do is to add it to the scene. This is going to be cube. And then we need to put this object or primitive shape in the vector collision object, like we did in the last video. And this is gonna be cube. And now what we're gonna do is to tell the planning scene to add our box, and we're gonna do it by using the add collision object method belonging to the planning scene interface class. We can sleep it for 4 seconds. Okay, till now nothing new with respect of what we have learned in the last video. So we can close it, and then this is something new where we are gonna attach the object that we have created to the robot. We can print a message on the terminal. Saying that I'm going to attach the object to the robot. And then we need to initialize the MoveIt messages attaches collision object instance, filling out information about which scene object will be attached to a specific link of the robot's body, and it will, in our case, it will be the gripper connector. So let's do it. and instantiates the attached collision object instance. It is belonging to the MoveIt messages. And then we need to set the link of which this object is attached to. And in our case, it will be our gripper connector. Then we need to tell what will be the object, and it's gonna be the what we have called cube. And then we need to apply this attached collision object to the scene. So we need to put current scene. Then we're gonna use the method apply attached collision object to the attached object that we have just created. Then we're gonna sleep for 4 seconds. So imagine that in this simulation we are gonna grasp the object, and this object is attached to our gripper robot. Then when we are gonna release the object, we need to detach it, okay? So now if here we have attached, now we need another function to detach the cube to our gripper connector, and this is what we're going to do now. So basically the structure is very similar to this. So we can copy and paste. So here we can comment this out attaching. And here there will be the detaching. So now what we need to do is to remove this object, and we are gonna use it cube dot operation, and then we need to remove. So it's gonna be cube dot remove. We move to what? To the attached object link name gripper connector. So now the object will be detached from the gripper connector. And basically from here on there will be the same piece of code. And then we can shut down. Okay, so basically the code is finished. Then I remember you that since this is a C++ code, what we need to do is to create a executable file from this script. So we need to update the cmake-list file. Okay, so now what we can do is to build the package and test it out. Sorry, make sure that you don't make my error. So it's not cube, it's gonna be a primitive box shape, and now it should be good. What we're gonna do is to run the demo launch file. And now we are gonna run the node that we have just created, and cube will be spawned in the 1 1 1 position, so it should be something like here. Okay, here. Let's do it. So open a new terminal and run the node. This is the executable file. Let's see if it's spawned correctly. Okay, you can see here is green, and then when it's turning red, it's meaning that it's attached to the robot, and then we wait for 4 seconds, and then it's detaching again. Okay, so here when it's turning red or purple, let's say, is that because we are here. So when it's attached, then it's turning purple. Then when it's detaching, it's turning green again. So what does it mean in practical? When it's going to be attached, so when we are gonna move the link where this object is attached to, that in our case is the gripper, then the object will move accordingly. And so let's try it. Okay, so we are gonna bring the end effector, then it's gonna turn red, purple, and then you can see here that is detaching. So we can make it again. So we start the end effector from here. Okay, so then the object will be something like here. Let's try it. Okay, it's attached, we move, and then it is attached again, detached again. So of course this will not be our case, because the object will be in attached to the gripper. So for example, what we can do is to take the position in translation and orientation by echoing the transform. Okay, something that we have seen in the last video. I'm gonna provide the link now. So let's do it. So first of all, let's reset everything. Run again. Okay, so how we can check and see where is gonna be our gripper connector here, the position. What we can do is to open a new terminal and run the transform echo tf echo, then we are gonna echoing the transform between the world frame and the gripper connector. Okay, we can see here the robot stands, and the translation is gonna be this one. Okay, so this will be the position in X, Y, and Z. In fact, the Z is going to be 1 meter point 8, and okay, it can be reasonable, the result. So let's test it and just copy and paste this value. Okay, so you can imagine that if we put this value, then the cube will appear at the correspondence of the origin of the gripper connector. So that is gonna be here, and so we need to add in the x direction the thickness of the cube and the thickness of the gripper connector itself. So it's going to be 30 millimeters, and then if we wanted to check what will be the thickness of the gripper connector, we just need to go into our cobot simulation package, URDF file, and I remember you that we put all the information on the gripper in this chakra file. And the gripper connector, okay, this is gonna be 30 as well. So we need to spawn the robots in plus 0.06. Okay, let's do it. So here is gonna be 0.8. Okay, let's test it. Well, first of all, you need to remember that you need to update your package. So let's launch the demo launch file. So we spawn our robots in RVs. Okay, then now the object should appear here at the inside the gripper connector. Okay, let's see. And here we go. You can see that there's the object that we have spawned in the position that we wanted, thanks to the transform echo. Okay, so now we can test it again. So run the attach detach object cobot no again, and then when it's turning purple, we are gonna change the position of the gripper connector, and as you can see here is moving accordingly the object. Okay, so in order to make the thing easier, let's extend the sleep time of the attaching and detaching, so we can better appreciate the usefulness of this. We can appreciate the fact that it's very useful, this node. So for example, let's attach for, let's say, 10 seconds. Okay. Okay, let's run. Here we go. And now it should be attached for 10 seconds. Imagine that we are gonna place the object here, and then it's gonna be released. Okay, so that's all for today. I hope that you enjoyed this video. If you like this video, make sure to subscribe to the channel and hit the notification bell to do not miss the next topic. And this is not a real pick-and-place application, but this is something that has been deployed in RVs. But basically, in the next video, we are gonna spawn it in gazebo, and what we're gonna use, we are gonna use this kind of node. We are gonna attach in an object to a gripper, and we're gonna detach. That this is a really good simulation of a pick-and-place application. Okay, thank you for your attention, and keep learning robotics with Ross.